Number 17, triangle FGH is similar to triangle JKL, where angle F corresponds to angle J and angles G and K are right angles. Okay, so FGH and angle G is a right angle. So I don't know what the proportions are, but you know, I can get kind of close. So I have FGH and G is a right angle. And I know JKL looks like it. It may be smaller, it may be bigger, I don't know. I'm drawing it smaller. And so JKL and K is a right angle. Now, normally when they say things like triangle FGH is similar to triangle JKL, when you see that written out, that means the corresponding angles, they correspond. And when I say that corresponding angles as they're listed, the corresponding points, those are, you know, showing the proportions here. So F corresponds to J, G corresponds to K, H corresponds to L. That's always the way it's done with similar figures. The order is telling you which point corresponds to which point. I hope I didn't say that too confusingly. So they're making it extra clear by saying angle F corresponds to angle J. But honestly, just from this information, triangle FGH is similar to triangle JKL. The first corresponds to the first, the second to the second, the third to the third. But they've told us F corresponds to J, so we're just going to write it just like that. It's okay. Now, if sine of F equals 308 over 317, what is the sine of J? So sine is talking about the relationship, the ratio of the lengths of sides in right triangles. And if I have two right triangles that are similar, as they are in this case, their proportions are identical. Now this is true, this general statement of similar triangles have identical proportions. That's true of any two things that are similar. Their sides, corresponding sides, if you're putting them in ratios, they're going to be the same ratios. The difference here, why the right triangle is special with the right angles, is that all those ratios are recorded. They have been determined, they have been observed, they have been recorded, so we know all of them. So here, I would know that if there is a particular angle, whatever angle this is, this degree, then if I took the length of the opposite side, and then I took a ruler and I measured the hypotenuse, and I divided those, no matter how big or small this triangle is, if it's a triangle, it has, like, let's say if this was a, 32 degrees, and then I measured both of those, every single solitary triangle in the world, 32 degrees, the opposite side divided by the hypotenuse is going to have that same ratio, and that is sine. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So again, same angles are going to have the same sine value no matter what size that triangle is. So they're telling us the sine of F, again, I don't know what F is, but it doesn't matter because I know F and J are the same angle. And if the sine of F is 308 over 317, every other angle that has the same measure as F is going to have that same sine. So there is no calculation required here. As soon as you know that F and J are the same angle, which they tell us right here, that angle F corresponds to angle J, you know the sine of these two angles is the same. So it is just B, again, 308 over 317. They may do something more unusual. They may go, oh, well, then what's the sine of L, or what's the sine, that is a possibility. Again, that's going to be, and I'm going to put links down below to videos on sine, cosine, and tangent if you're wanting to expand your knowledge and, and learn some more about those different types of problems where they're putting in those different trigonometric identities is the term for that. But in this particular problem, they're telling you the sine of F, and they're wanting to know what's the sine of J. It would have been the exact same situation if this had been cosine of F is blah, blah, blah. And then what is the cosine of J? They're the same angle. Their identities, trigonometric identities, are the same. 308 over 317. That's B. Hey guys, if this was helpful or useful in any way, please let YouTube know so I can keep helping you and others like you. Comment, like, share, subscribe, you know the drill. Also, if you're interested in practical or fun math-related items like this math clock or this hopefully humorous t-shirt, click on the links down below to check out my Spreadshop and Etsy stores. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.